The trigonometric ratio is one of the basic concepts of trigonometry. It is defined as the ratio between any two sides of a right-angled triangle. The ratio between the opposite side and the hypotenuse is the sine. The ratio between the adjacent side and the hypotenuse is the cosine, while the tangent is the ratio between the opposite side and the adjacent side. If a right-angled triangle is given, we can find the length of the other two sides when the acute angle and the length of one side of this triangle are known. The values of trigonometric ratios are specific integers or fractions when the angles of a right-angled triangle are special angles. In a right-angled triangle, when an angle is 30 degrees, sine 30 degrees is 1/2. Cosine 30 degrees is the square root of 3 over 2. Tangent 30 degrees is 1 over the square root of 3. When an angle is 45 degrees, sine 45 degrees is 1 over the square root of 2. Cosine 45 degrees is 1 over the square root of 2. Tangent 45 degrees is 1. When an angle is 60 degrees, sine 60 degrees is the square root of 3 over 2. Cosine 60 degrees is 1/2. Tangent 60 degrees is the square root of 3. The trigonometric ratios of these special angles are quite useful, as they allow us to find numeric results without using the calculator. Let's look at this right-angled triangle. Angle C is a right angle. Angle A and angle B are complementary angles. We end up with these basic trigonometric identities through the use of trigonometric ratios. Now we can use these basic trigonometric identities for calculations or problem solving. Let's try this problem. There is a trigonometric expression, tangent theta multiplied by tangent 90 degrees minus theta minus cosine squared theta. Let's use trigonometric identities to simplify this expression. Since tangent 90 degrees minus theta is equal to 1 over tangent theta, and sine squared theta plus cosine squared theta equals 1, after simplifying the expression, the result is sine squared theta. Here's another problem for you to solve. Between 45 degrees and 90 degrees is the value of tangent theta greater than sine theta, the value of tangent theta greater than cosine theta, or the value of cosine theta greater than sine theta. Tangent 45 degrees is 1. Sine 45 degrees and cosine 45 degrees are 1 over the square root of 2. Tangent 45 degrees is greater than sine 45 degrees, as well as cosine 45 degrees. Also, from 45 degrees to 90 degrees, the values of sine increase. Conversely, the values of cosine decrease from 45 degrees to 90 degrees. If you're observant and understand the concept of trigonometric ratios clearly, the answer is A. That is, tangent theta is greater than sine theta, tangent theta is greater than cosine theta. This is a line segment OA. If OA is rotated about point O through an angle theta, then angle theta is called the angle of rotation. In addition, OA is called the initial side. OB is called the terminal side. And point O is called the vertex of angle theta. When the angle theta is placed on a rectangular coordinate plane, such that the vertex of angle theta is located at the origin O, and the initial side OA coincides with the positive x-axis, then angle theta is said to be in standard position. These two situations are angle theta in standard position. One point should be noted. If an angle is formed by rotating OA in an anti-clockwise direction about the origin, then the angle formed is a positive angle. Conversely, if an angle is formed by rotating OA in a clockwise direction about the origin, the angle formed is a negative angle. When angle theta is greater than 0 but less than 90 degrees, it lies in the first quadrant. When angle theta is greater than 90 degrees but less than 180 degrees, it lies in the second quadrant. When angle theta is greater than 180 degrees but less than 270 degrees, it lies in the third quadrant. When the angle theta is greater than 270 degrees but less than 360 degrees, it lies in the fourth quadrant. In some cases, an angle is greater than 360 degrees or it is a negative angle. You may wonder which quadrant this angle lies in. This is determined by the final quadrant of the terminal side. In fact, two angles in standard position with terminal sides coinciding are called coterminal angles. For example, an angle of 30 degrees and another of 390 degrees both have terminal sides lying in the first quadrant. They are coterminal angles. Please note that coterminal angles are not equal angles. Previously, we discussed the definitions of trigonometric ratios of an acute angle. However, these ratios are not applicable to angles greater than 90 degrees or less than 0 degrees. This is because we can't construct a right-angled triangle with an angle greater than 90 degrees or a negative angle. But don't worry, we can extend the definitions of trigonometric ratios of any angle by making use of the angle of rotation. When we define the trigonometric ratios of any angle, we can place a right-angled triangle on a rectangular coordinate plane. Angle theta lies in the first quadrant. Triangle OPQ also lies in the first quadrant. X, Y is the coordinate of point P. R is the length of OP. That is the square root of x squared plus y squared. Consequently, sine theta is equal to y over r. Cosine theta is equal to x over r. And tangent theta is equal to y over x. When angle theta lies in the second quadrant, the triangle also lies in the second quadrant. The value of x is negative, but the values of y and r are positive in the second quadrant. Therefore, the values of the sine ratio are positive. However, as the value of x is negative and the value of r is positive, the values of the cosine ratio in the second quadrant are negative. Lastly, since the value of y is positive but the value of x is negative, the values of the tangent ratio in the second quadrant are also negative. When angle theta lies in the third quadrant, the triangle also lies in the third quadrant. The values of x and y are negative, but the value of r is positive in the third quadrant. Therefore, in the third quadrant, the values of the sine and cosine ratios are negative, while the values of the tangent ratio are positive. When angle theta lies in the fourth quadrant, the triangle also lies in the fourth quadrant. The value of y is negative, but the values of r and x are positive in the fourth quadrant. Therefore, the values of the sine ratio in the fourth quadrant are negative, the values of the cosine ratio positive, and the values of the tangent ratio negative. Sometimes we can't determine which quadrant an angle lies in. When solving this kind of problem, the answer may be incomplete. Let's look at this example. Here is a trigonometric expression. Given that cosine theta is equal to negative 3 over 5, find the values of sine theta and tangent theta. Since cosine theta is negative, it may lie in the second or third quadrant. The same goes for angle theta. When solving this problem of trigonometric ratios of any angle, results in both the second and third quadrant are considered. Situation 1. When theta lies in the second quadrant, the x-coordinate of P is negative. Since x is equal to negative 3 units and r is equal to 5 units, by using Pythagoras' theorem, we find that y is equal to 4 units. Then we have sine theta is equal to 4 over 5. Tangent theta is equal to 4 over negative 3, or negative 4 over 3. Situation 2. When theta lies in the third quadrant, the x-coordinate is negative, and so is the y-coordinate. Since x is equal to negative 3 units, and r is equal to 5 units, by using Pythagoras' theorem, we find that y is equal to negative 4 units. Then sine theta is equal to negative 4 over 5, and tangent theta is equal to negative 4 over negative 3, or 4 over 3. We have already discussed the trigonometric ratios of any angle and used them to solve problems. We also understand that whether a trigonometric ratio is positive or negative depends on which quadrant the angle lies in. We can summarize the results with a CAST diagram. In the first quadrant, all trigonometric ratios are positive. In the second quadrant, only the sine ratio is positive. In the third quadrant, only the tangent ratio is positive. In the fourth quadrant, only the cosine ratio is positive. We often hear about trigonometric functions, so what are they, and what do the graphs of these trigonometric functions look like? For any angle theta, there is only one corresponding value for each trigonometric ratio. Hence, each trigonometric ratio is a function of theta. In function notation, we can write them like this. The function of theta is equal to sine theta. The function of theta is equal to cosine theta. The function of theta is equal to tangent theta. Or, y is equal to sine theta, y is equal to cosine theta, y is equal to tangent theta. These functions are called the sine function, the cosine function, and the tangent function respectively. In general, they're called trigonometric functions. On a rectangular coordinate plane, the circle centered at O with a 1-unit radius is called the unit circle. Let's discuss the graphs of these trigonometric functions based on the unit circle. First, let's construct a perpendicular line P pi. P pi is perpendicular to the x-axis. A right-angled triangle OP pi is formed. The length of OP is 1 unit. The length of P pi is y units. And the length of OP pi is x units. In the unit circle, the radius is 1 unit. Sine theta is equal to y. Cosine theta is equal to x. Tangent theta is equal to y over x. Now let's investigate the graph of the sine function. This is the table of angle theta from 0 degrees to 360 degrees, and the various values of sine theta. When angle theta increases from 0 degrees to 90 degrees, the values of sine theta increase from 0 to 1. When angle theta increases from 90 degrees to 180 degrees, the values of sine theta decrease from 1 to 0. When angle theta increases from 180 degrees to 270 degrees, the values of sine theta decrease from 0 to -1. When angle theta increases from 270 degrees to 360 degrees, the values of sine theta increase from -1 to 0. The relationship between angle theta and sine theta is shown by a graph like this. This is the graph of the sine function. We can observe that when angle theta is equal to 90 degrees, sine theta is equal to 1. This is the maximum value of sine theta. When angle theta is equal to 270 degrees, sine theta is equal to -1. This is the minimum value of sine theta. If angle theta keeps increasing, and we continue to plot the relationship of angle theta and sine theta on a graph, we observe that the graph of the sine function repeats itself every 360 degrees. We say that the sine function is a periodic function with a period of 360 degrees. Now let's look at the graph of the cosine function. This is the table of angle theta from 0 degrees to 360 degrees, and the various values of cosine theta. The relationship between angle theta and cosine theta is shown by a graph like this. When angle theta increases from 0 degrees to 90 degrees, the values of cosine theta decrease from 1 to 0. When angle theta increases from 90 degrees to 180 degrees, the values of cosine theta decrease from 0 to -1. When angle theta increases from 180 degrees to 270 degrees, the values of cosine theta increase from -1 to 0. When angle theta increases from 270 degrees to 360 degrees, the values of cosine theta increase from 0 to 1. This is the graph of the cosine function. We can observe that when angle theta is equal to 0 degrees, cosine theta is equal to 1. This is a maximum value of cosine theta. When angle theta is equal to 180 degrees, cosine theta is equal to -1. This is the minimum value of cosine theta. If angle theta keeps increasing, and we continue to plot the relationship of angle theta and cosine theta on a graph, we observe that the graph of the cosine function repeats itself every 360 degrees. We also say that the cosine function is a periodic function with a period of 360 degrees. We have already studied the graphs of two trigonometric functions. The last graph for investigation is the tangent function. This is a table of angle theta from 0 degrees to 360 degrees, and the various values of tangent theta. The relationship between angle theta and tangent theta is shown by a graph like this. When angle theta increases from 0 degrees to 90 degrees, the values of tangent theta increase from 0 to positive infinity. When angle theta increases from 90 degrees to 180 degrees, the values of tangent theta increase from negative infinity to 0. When angle theta increases from 180 degrees to 270 degrees, the values of tangent theta increase from 0 to positive infinity. When angle theta increases from 270 degrees to 360 degrees, the values of tangent theta increase from negative infinity to 0. This is the graph of the tangent function. The tangent function has neither maximum nor minimum values. The graph of the tangent function is discontinuous when angle theta is equal to 90 degrees and 270 degrees. If angle theta keeps increasing, and we continue to plot the relationship of angle theta and tangent theta on a graph, we observe that the graph of the tangent function repeats itself every 180 degrees. So we say that the tangent function is a periodic function with a period of 180 degrees. Here are two graphs. Let's examine them and find their maximum and minimum values and determine whether these two trigonometric functions are periodic functions. We observe from this graph that the maximum value of the function is 1 and the minimum value is negative 1. This is a periodic function with a period of 120 degrees. In this graph, we observe that the maximum value of the function is 2 and the minimum value is 0. This is also a periodic function, but with a period of 180 degrees. In the final part of this program, let's explore the trigonometric identities of any angle. I will also share my learning experience with you. Here are some popular trigonometric identities of any angle. It seems difficult to memorize them, but don't worry. Do you notice that the trigonometric ratios are the same whenever the angle is added or subtracted by 180 degrees or 360 degrees? But the sign is different. We can make use of the CAST diagram to memorize the corresponding signs of different trigonometric ratios. For the trigonometric identities of 90 degrees minus an acute angle, we have already discussed them at the beginning of this program. You have also learned about them in Key Stage 3 of secondary school. Here are the trigonometric identities of 90 degrees plus an angle theta. The results are the same as 90 degrees minus an acute angle, but the sign is opposite, with the exception of the sign ratio. To end this program, let's solve a problem from a past public examination.